have to know about water saturation, because when you are going to do modeling, at the end, you are going to get the results. So you have to compare, like, I've got this kind of, for example, you have got 15% porosity of 15%. So you need to know, like, if my reservoir have this kind of percent, then is it a good reservoir or poor reservoir? Like, you have to evaluate something like that one. So having the knowledge about the log type, like, we know we have limestone, we have sandstone. So carbonate reservoir, we know, like, you have to know the characteristics of them. So it also, it's important for you, before you start doing modeling, reservoir modeling, you need to know about structure and basin. Like, you need to have the knowledge of basin, what is basin, what is required, what is the minimal requirement for you for a basin to be called a basin. Also, there's some difference here. For those who are more interested, you can just go and search. Once you get this one, then you'll be able, you can see the difference here. Like I'm saying, you can just read in order to get a lot of understanding and to be aware of what you're going to do when you're going to build a reservoir model. So apart from this, also we need also I'm just moving direct to our introduction. This is lecture number 1. So we know, both of us, all of us, like, reservoir is a potential reservoir. It's any log with void in which petroleum can accumulate. So this is one of the very characteristics of a reservoir. Like, it should have a void in which petroleum can accumulate. So for us, we're going to do a reservoir modeling. So there's someone there are some sounds which are interrupting. I don't know who is on. I can hear some voice. Please, anyone who is, just mute your mic, please. Okay, thank you. So a reservoir, as I've said, we are petroleum expertise, so then we know it's a log, or any log with void in which petroleum can accumulate. It must be porous. So these are the just basics which you need to understand and to know. So as you can see there, we have like a picture which show the anticline, and we have a fault. Up here we can see, like, we have here an anticline structure where our gas and oil are accumulated. So down here we see there is generation of migration of petroleum from the source rock to the reservoir. So these are just some knowledge which you need to have. So all this which I can show here are just one of the part of our reservoir. Like, a reservoir is supposed to be a porous. It's supposed to have a void space which can accumulate our hydrocarbons in place. So we do have different kind of reservoir log. So some of it is sandstone, which is very common. I think most of our reservoir are comprised of sandstone, but also in part of the world we have limestone, or we call them as carbonate reservoir. So here, once we continue, we know that in the limestone or carbonate reservoir, they do have a certain characteristic. Like, when you want to correlate about the porosity and permeability, they do vary. Sometimes you may find on the carbonate reservoir, some of them, they do have high porosity, but they have poor permeability. So which make them to have a certain characteristic, which is, of course, it's something harder, like to explain, or during exploitation of hydrocarbons, it make it harder, like, for the expertise to harness the hydrocarbon from a reservoir. So all these are the key points we need to have. We need to have when we want to do reservoir modeling. First of all, you need to know, like, which type of log do you have in your area where you're going to do a modeling. So Also, in reservoir modeling, like other important data which we need to acquire is seismic. So we do here, like we have different kind of seismic data, but now we have up to 3D seismic data. Like all this information help us to build our reservoir modeling. So I'm just giving up the introduction, but here we can see how oil and gas deposits are found. So we found oil or gas deposit by using seismic. So seismic, once we acquire the seismic acquisition, so we need to process it, to interpret it, and then we use that kind of information also to build reservoir modeling. So all these are just some of the data and information which are really needed when you want to do reservoir modeling. So also we are going to see, when we are going to do reservoir modeling, we will see different kind of structure. Like we have seen, we have anticline, we have fault reservoir. So once we do our modeling, these are the key features we need to see. We import some data. We have some just digit data. So once we import them to the software, at the end, because I've said you need to have that knowledge. Like I have a knowledge about maybe the reservoir architecture, the way it is an anticline. So once I'm building this reservoir model, once I'm creating a reservoir model, so because we have did preliminary studies, like we know about the outcrop, we have seen different kind of structures in our basin. So now when we are going to create this architecture of the reservoir, so we need to see what we have in our mind. So sometimes if somebody just came and then they said, okay, I want to create or to build a reservoir model, and then you have a model which is not correlating or which is not relating, which is not relating, like it's not a picture of maybe an anticline. So at your mind, you have to have that knowledge, like I'm going to build a reservoir model, but at the end, if your reservoir is in anticline structure, then you have to see it. After importing your data, building your data, and then you need to see this kind of the architecture of your reservoir. If it's a fault, also you need to see it. So these are the most important information you need to have before building or before starting building the reservoir model. So mostly in this training or in this workshop, because today I will just give you the overview in this 1 hour, but from tomorrow I will be showing you, from my computer here. I'll just show you the procedures on how to build the model from scratch. So now the software which you're going to use is Petrel for exploration and production software platform. So Petrel is well known, and the companies, I think we know all the companies. For the companies which are producing this one, they call them Scramblers. I think everyone knows they're the one who developed this software. So we'll be using student version. So Petrel is one of the software which will be used for exploration and production sector. So it will allow us, like we'll be using this software. For those who don't know about Petrel, Petrel can allow the user to interpret the seismic data. Also, we will perform well correlation. We will build reservoir models, the one which we are going to do in our training. Also, by using Petrel, we visualize the reservoir simulation results. Also, we can calculate volumes, produce maps, and design development strategies to maximize reservoir exploration. Risk and uncertainties can be assessed through the life of the reservoir. So we are going to use Petrel. So now, from all those information I've just given, so let's now define what is a reservoir modeling. So in oil and gas industry, reservoir model involve the construction of computer model of a petroleum reservoir for the purpose of improving estimation of reserve and making decisions regarding development of the field. Also predicting future production. Also, we are going to say about placing additional well and evaluating alternative reservoir management scenarios. So when we talk about reservoir modeling, it means it's just a computer, like somebody is using, you are just using your computer, you're just seated there, and then you get some of the data from different discipline, like from those who are doing logging, they'll just give you some information from data. Those who drill the well, they'll give you that information, and then they will give you information about the well. Also, you just get information from those who did seismic. So once they gather all the information, all the data, you are the petroleum geologist or a reservoir engineer. You just be seated to your computer and then you install the software. The next stage, like you just take all those information, all those data, kind of data, and then you start importing, editing those kind of data, and then you import them to the software. So the purpose of you gather all the information, like you take the well data, maybe the location of the well, the depth of the well, and all the information about the well which have been drilled, and then you just gather other information, maybe the seismic and the petrophysical information together. You just import them to the software, which we call, for our case, we're going to use Petrel. So you gather all those information, and then you import them to the software, and then the software will construct a computer model of your reservoir. So all this kind of information which will be given to you will be concerning the architecture of the reservoir. So you will know, like, at which depths maybe you have encountered sandstone, at which information, at which depths you have encountered, maybe there is something like, maybe you have something like, you have some information like those kind of data, different kind of data, petrophysical data, you have seismic. So when you gather together and then you import to the Petrel, which is the software, it will construct for you. You will construct, of course, there's some procedure on how to construct. You will construct using those data, and you create a computer model. This kind of computer model, it's the one which you are going to call it a petroleum reservoir mod, or a reservoir modeling. So we have different kind of model, like some, when you use other software, there's some software, we call it Petrel mod. You can create a model of a basin. Like we know a basin, it will just construct each information about the basin, like the thermal maturation, something like that, like all those kind of information from the maturity rate and something like that. But for the reservoir modeling, you are just constructing the architecture and the structure of the reservoir, of our reservoir. So all those information after constructing that kind of reservoir architecture. So what is the purpose of doing this? So we are constructing the reservoir so that to improve the estimation. We know that in the petroleum field, it's too costly for like to drill a lot of wells in a field. So we usually drill, maybe you have maybe you have a basin, you can have maybe some even 14 or 15 wells. So some of the information in between from one well to another well, there is unknown information of that area. So one of the purpose of creating a reservoir model is like, now after creating a reservoir model, we now need to estimate, to improve our estimation, because we know when on the exploration stage, in expression stage, one of the function like of the petroleum geoscientist, they just estimate the reserve we would have in our reservoir. So now for you to create a reservoir model, also it will help you like to estimate also the amount of hydrocarbon in our reservoir. Also, another important or another purpose of doing this to make decision. For example, we need we need maybe to drill another well or to place another well, production well. We will use that model like to place. We know, okay, in the future we're going to place another well in a certain distance or in a certain coordinates. So this is one of the purpose of doing reservoir modeling, and that's why like it's important for us to understand and to know the issues of petroleum of reservoir model. So basically we have different types of reservoir model, but for reservoir model we only have two types. Mainly we have two types. The first one is called geological model, and the second one is called a reservoir model. But for geological model, mostly are created by geologists. So geologists are the one, geologists and geophysicists, and that aims to create this kind of geological model. Sometimes a geological model, we call it a static model, because it basically going to calculate the amount of hydrocarbon in place. So we just calculate the amount of hydrocarbon in place before being disturbed by production and something like that. So for us, our intention or our purpose of creating a reservoir model is to create a static model of our reservoir. So the second type, we call it a reservoir simulation. In another word, we call it a dynamic model, So mostly are created by reservoir engineer, and they use finite difference methods to simulate the flow of fluid with the reservoir over its production lifetime. So for this step number 2, this what we call a dynamic model or a reservoir simulation model is when also after creating a geological model, which is a static model from geologists, now that model will be imported to a simulation. So for those who will be interested in this class, so we are going to learn also simulation, but for the simulation case, we are going to use another software which is called Eclipse. So Eclipse we will change the static model, which is geological model, which was created by geologists. Then now we will start simulating the hydrocarbons which are in place. We place the well and then we simulate. So when we call reservoir simulation, it means we start simulating the flow of fluid from the reservoir. So for the first model, which is geological model, for it it's just concerned with the static model. This one, the one I'm just explaining. For this one is just it's just concerned with static description, like we have our hydrocarbon in place without disturbing them, without making them flow from the reservoir. So that is what we call a geological model or a static model. But for the second one, this is reservoir simulation. For it is where now we start simulating the hydrocarbon from a geological model or from a static model. We start simulating the fluid and to see like how much will be produced when we place a well at a certain distance in a reservoir. So, but for this one, for the second one, for the reservoir simulation, it will be done by engineers, especially reservoir engineer. But it's most important, like if you want to be a reservoir engineer, to be a good reservoir engineer, the first thing you need to have like a knowledge about the geological model. So apart from those two, now building a 3D reservoir modeling, geological modeling. Building a geological model to examine different development plans. These are just why are we building the 3D, or why are we building a reservoir model? So it's just we build them like like I've said, like to estimate the hydrocarbons. So these are the objectives: to estimate or to calculate the initial volume in place. Also, optimization of drainage strategy for hydrocarbon field. But for the second one, for this one, mostly we use them. It is used after importing or exporting our model to the simulation strategy. So also the objective of using the 3D of building the reservoir model for calculation of recoverable volume. So once we create or once we build our model, we're going to see when the software is run, we will see like how much hydrocarbon can be recovered and how much cannot be recoverable. So we can also calculate the volume of the recoverable volume. Also, we are going to see the generation of production profile. We are going also to see about the evaluation, generation, depression plan as the plan tools to deter replacement, production, and injection well. So when we move to the second model, because once we create a static model, and then when we start creating the second, like the static, when we export our model from static to dynamic, one of the key function when we are learning simulation, we evaluate the recovery factor, like how much if you place one well maybe at a certain distance or at a certain coordinate, and we simulate, we see the production. We know that while producing, like pressure will be decreasing, so it will reach a time like we cannot recover a lot of oil or gas in a certain reservoir because pressure is down, so we need to enhance production. So placing another well, we need also to use a model. Like the company cannot just say, okay, let's go and inject another well in any place. They first need to learn some simulation, to go to the modeling and to learn some simulation to see if it's economical to place another well and to find out the optimal location for them to place another well. So this is also one of the objectives of why we are doing reservoir modeling. Also, digital reservoir model may serve different purposes, and we typically distinguish between a static reservoir model and dynamic reservoir model. So all these two types of geological modeling are the key points why we need to understand them first and to create them. So in this training, basically, we are going to be moving around through these two types of reservoir modeling. But mostly for Petrel, as I've said, we are going to stick on the static reservoir modeling. So we're just going to create a static model. And our objective is for the static reservoir model, this one, the one with lead, our objective of creating the static reservoir model is just for the purpose of calculating the amount of oil in place. So please note this and write it down. Like the purpose of static reservoir model, the one we are going to do, like we are building a model just to calculate the amount of oil in place or gas in place. So that is the purpose. Our purpose is just to create, to calculate that one. So through pathing or through creating that kind of, through that, attaining that objective, that's why we'll be passing through different stages. So we'll start by importing the data, preparing the data, importing the data. We'll do we'll pass through different stages. So after we finish, at the end of creating the model, we'll be able now to know, like, okay, in this kind of reservoir, we have a certain amount of hydrocarbon in place. So that is our main objective. So after knowing the amount of oil or gas in place, then we will use that model. We will export that model to be a dynamic model. Then for dynamic model is where now we are going to see something called a reservoir simulation model. So which is called a dynamic reservoir model. So from there now we will learn some simulation, we will test different scenarios of production, we'll test a different kind of scenario of enhancing oil production, and we'll do a different kind of scenarios, placing wells into different direction. So it will help us also to decide an optimal location for placing a new well for injection or for production. So it's very, very important in this world and in petroleum field, like to have this knowledge of how to create this reservoir model, because of course most companies now, they are learning away from using a lot of capital, so they don't need to guess like where we can place a well. So they need just to use the software. You just seated in the office, learning different scenarios, testing, and then they will, once they decide, okay, let's go and drill this well in this coordinate, and then they will just have a cool decision like, it's true, now we are going to get oil, and it will be optimal for us, and it will be economical for us. So in order, software evolution of this software, it helped a lot of companies like to reduce costs. Before they used to drill a lot of wells just to test, okay, let's try to drill here, let's try to drill here. So it was costing them a lot of money. They were using a lot of money so that to attain, like to get that kind of hydrocarbon. As we know, like it cost a lot of money, like $10 million, $10 million, like to drill just one well. So that's why evolution or using this kind of software training, software modeling, like it helps the company to reduce the amount. It helps the companies to reduce the money they're going to spend when using, or like when you want to implement or to put another well. So enhanced geological understanding. Let's go back. Petrel software, the one which we are going to use, like as I've said, it's for exploration and production. And then within the single environment, geoscientists can perform the key of geological workflow from stratigraphy, seismic interpretation, through fractures, facies, and geocellular property modeling to history matching and production simulation. So all these functions, like they can be implemented using our software, which is called Petrel E&P software platform. So like we're saying, for example, as you can see here, what we have seen, like I've said, what we see them from our picture, from the seismic. So sometimes we can get some of the information which are in 1D, for example. Then you can use that kind of information to run into the software and to create a 3D, because we're going to use Petrel, so it just gives us a 3D reservoir model architecture. So it's more good for, it's accurate, and it's more good for viewing and to see the architecture of our reservoir. So we can say, for example, in this picture, you can see you just have a 2D picture. Maybe it's a seismic or something like any map. So when you can use this map, and then you can transform it to the 3D. So 3D is nowadays, as we know, we use 3D mostly to visualize, to have a good picture of what we are going to see. So it gives you a lot of details when we use 3D geological model. So step here, I'll just show you some steps which you are going to pass through when you want to create that static model or a geological model, which is supposed to be built by reservoir engineers or geologists. So the step for building a new static model, when starting a new project for Petrel, first we have to input data into our input panel. So from tomorrow, because I've said just today, it's just an introduction, but from tomorrow, I will just be showing you some of the procedures on how we are going to import and how are we going to to import to import the data to our software. But here are just some of the steps which we need to use when we want to build a 3D geological model, which is static. First, to input data, we are going to add data. We need to do well correlation. After doing well correlation, we are going to do a fault modeling. There is something called pillar grading, vertical layering, geometrical property modeling, upscaling for vertical direction and well logs, facies modeling. Also, we're going to do petrophysical modeling, define fluid contact and volumes and the volume calculation. So this will be our last objective. Like at the end of creating a geological model, we now need to come up with how much we have seen in our reserve. So this is very important feature, and this is very important studies. You as a petroleum expertise, you need to understand, like from the beginning to the end. So guys, I just wanted to give you an introduction about Petrel reservoir modeling. So if you have any question, please now let me listen from the audience, and then I can respond on the questions from now. Now you're welcome. So I think for today, this will be an introduction. If you have any question, just send it, or you can ask the moderator of our class, and then I will respond on the question. Now you're welcome. Welcome everyone. I think I need to hear from the...
Hello.
Okay.
Are you
Hello?
listening me?
Yeah, I can hear you.
Sir, basically I want to say that for today, if you are modeling this reservoir, so please give us the link of or provide us some data so we can practice on some seismic data.
Okay, thanks. So I think I will share to you, everyone, I will ask the moderator to send for us the link for our WhatsApp group. Then I will share to you today where you can get our software and then the data, okay? So for those who don't have the data, I will just share the data there, and then I will share the link for our software. So then from there, you can just download the software and you can download the data. So from tomorrow,